Today we're going to begin our look at rational exponents. Now a reminder that rational just means the ratio of two things, or you can think of it as a fraction. So what we're dealing with today would be something like, what does it mean to have 2 to the power of 5/9? How do we make sense of this kind of an exponent? And this is where our thinking about exponents as repeated multiplication really breaks down. So we've got to think about what that means a little bit. We're going to start by focusing on the denominator. So imagine for a minute that we had x to the 1/2. This is in what's called exponential form. And exponential form is directly related to radical form. So if I wanted to write x to the 1/2 in radical form, I would write it as the square root of x. And I know it's a square root because the denominator is 2. Someone might be asking, well, where'd the 1 go? Well, it's x to the first. In a rational exponent, the denominator is the index of your root, and the numerator is the power on your base. Let's translate a couple more. Imagine we had x to the 1/3. Well, if I wanted to write x to the 1/3 in radical form, this would just be the cube root of x. Let's try one more. What about if we had x to the 1/5? Well, in radical form, this would be the 5th root of x. The denominator of your exponent is the index of the root. Why don't you try these three? Go ahead and translate t to the 1/2, m to the 1/3, and r to the 1/4. Well, if you did it correctly, t to the 1/2 is the same thing as the square root of t, and m to the 1/3 is the same thing as the cube root of m, and r to the 1/4 is the same thing as the 4th root of r, because in a rational exponent, the denominator and the index of the radical are the same. Well, once we're comfortable translating from exponential form to radical form, then we should be able to go backwards. Here I'm going to rewrite these that are in radical form into exponential form. The square root of x is the same thing as x to the 1/2, because the denominator is the same as the index. In the second problem, we have the cube root of y. Well, if I'm going to write that in radical form, it would be y to the 1/3. And finally, the 4th root of z is the same thing as z to the 1/4. The denominator in your exponent is the same as the index on the radical. Why don't you try these three? We've got the 5th root of a, the 21st root of b, and the 193rd root of c. Well, the first one is just a to the 1/5 power, because the denominator and the index are the same, or they're related. For the second one, it would be b to the 1/21st power. And the last one, it would be c to the 1/193rd power. I bet you're getting the hang of it. Let's take it one step further. Here we have some that are just a little more complicated, but nothing's different. The first, we have the square root of 5y. So if we wanted to rewrite that in exponential form, well, the radicand is 5y. So that's my base number. And my exponent would be to the 1/2. Notice the entire radicand is now the base number. In the second one, I have the cube root of 4x. Well, that would be 4x to the 1/3. The third one's slightly different. We have 3 times the 4th root of 5z. Well, nothing's going on with the 3, so that'll stay as 3 times something. 5z is what the radicand is, And since it's the fourth root, it'd be 5z to the 1/4 power. Why don't you try a couple on your own? Why don't you try these three? The square root of 10m, the cube root of 3n, and 5 times the fourth root of 6y. We want to translate these into exponential form. Hit pause, see what you can do. On the first one, this is the same thing as 10m to the 1/2 power. On the second one, this is 3n to the 1/3 power. On the last one, we have 5 times 6y to the 1/4 power.